Hello, good morning all. This is the 21st lecture of your C programming lecture series. Today we will discuss two-dimensional array in C, that is array third. This is your third class of your array, okay? So already we discussed about one-dimensional array, okay? So in one-dimensional array we already discussed about what is an array, how to declare an array, how to initialize an array, how the elements are stored in an array, and everything, address of an array, everything we did discussed about an array in your first two classes regarding an array. Today we'll discuss that is two-dimensional array in details. Okay, let us come to in two-dimensional array. This is, as you can say, this can also be called as multi-dimensional array. First of all, you need to understand what do you mean by multiple dimension or multi-dimension, okay? So whenever I am saying it is multi-dimensional array, that means when you have more than one dimension, this is more than one dimension, okay? So already we discussed about what is that one dimension. For example, if I say this is an integer array that is P of 5, okay? So the elements are 10, 12, 14, 16, 18. These are the 5 elements. How do we represent logically? This is a logical representation having 5 different divisions where we are going to store the elements 10, 12, 14, 16 and 18. This is your one dimension, okay? Similarly, this is your one dimension. Similarly, we can add one more dimension to this. Similarly, we can add another row like this, okay? So let it be 20, 21, 22, 24, 26, 30, 31, 32, 36, 38, okay? So this is your one row. All the 5 elements are in one row. I can add more such rows, okay? And I can combine them to form like this. It will have 3 rows and 5 columns. So it will start with 10, end with 18, first row, second 20, 26, then 30 to 38. So you can fill remaining elements over here. So whenever I am joining this is looking like a matrix format. So in matrix format, how many rows are there? Here you have first row, second row, third row. How many columns you have there? There are 5 columns, okay? So when you have rows as well as columns, that means I am combining an array, okay, which is having row and column. I can take row as one dimension, column as one dimension. So this will become your 3 dimension, okay? So how to declare these elements? Suppose if I have 2 dimension, then to declare 2-dimensional array. So coming to 2 dimension, this is also represented like this 2D. This is also called as array of array. Okay, that means this is my array, that means combination of similar elements. Okay, so this is here I am representing 1 dimension array. So if I'll take the similar kind of rows and combine them to form a group, so this is called, that means if I am taking combination of multiple one-dimensional array, then that becomes your two-dimensional array. So I can represent this as array of array. Okay. So coming to this part, array of array, how to declare them? So let this be declaration of two-dimensional array. So as it is two-dimensional, so it will have two dimensions. For example, if I am taking example integer p, so you will have two brackets, one is representing row, another is representing column. So here in the above diagram, you can see there are 3 rows and these 3 rows as well as 5 columns. So first dimension will be representing rows, second dimension will be representing columns, right? So the first dimension will always represent rows, the second dimension will always represent column. Then how many elements this array, two-dimensional array will contain? So the number of elements can be number of rows multiplied by number of columns, that is 15. So you can see from the diagram itself, yes, in every row I have 5 elements, 5 plus 5 plus 5. So all total 15 elements. Okay, this is called as dimension. Similarly, if I say that it is a 3-dimensional array, just you will have to add another bracket and you need to mention the now what is the dimension you are adding in another direction. Suppose assume that this is a cube. Okay, cube means let me represent the declaration of 3-dimensional array. Let me write declaration of, if this is a 3-dimensional array, then you need to add another dimension. For example, integer x, 2 rows, 2 columns, then another 2. Okay, so here in this way there should be a semicolon in the declaration itself. So this is the way you have to represent 3 dimensions. So in number of elements in 3 dimension will be 2 into 2 into 2. There are 8 elements. So how can you represent this? So you will have 2 rows, 2 columns. So in this direction, okay, so this is my one direction, this is one dimensional, this is another dimension, this is another dimension. Okay, so you can see, just ignore, just leave this part. So to make the diagram complete, I just draw the whole cube. Just leave this part, ignore this part. Okay, so you can see that whenever I'm extending the elements in 3 directions, so this is one direction, this is one direction, this is another direction. 1 2 3 4 5 6 7 8. Okay, so this is 1 2 3 4 5 6 7 8. Okay, so this is all about a multi-dimensional element. Okay, so how to represent, how to index this two-dimensional or three-dimensional array. Okay, so the first whenever I am considering this as a row, so this is my, as the array index starts from 0, so this is my 0th row, this is my first row, this is my second row. This is 0th column, this is first column, this is second column, this is third column, this is fourth column. As you have 5 columns, so it should be indexed from 0 to 4. So this element is nothing but your 0, 0. This element is nothing but your 0, 1. This element is nothing but your 0, 2. This element is nothing but your 0, 3. This element is 0, 4. This element is, this is 1, 0. Okay. This element is 1, 1. This element is 1, 2. This element is 1, 3. This element is 1, 4. This is 2, 0. So this element is 2, 0. This element is 2, 1. This is 2, 2. This is 2, 3. This is 2, 4. This is how we will be indexing the elements of an array. Okay. Clear? So how to access individual elements? So suppose this is my P array, then how do I address individual elements? So here in case of two-dimensional array, the first element would be, that is implies P of 0, 0. I'll write like this. So what will P of 0, 0? P of 0 is 10. Okay. So you can see that this is 10, this is 12, this is 14, this is 16, this is 18, 20, 21, 22, 24, 26, 30, 31, 32, 36, 38. So the first element would be 0, 0, that is P of 0, 0 equal to 10. The second element would be, that is P of 0, 1, that is 12. Okay. Similarly, you will access individual element. This is first, second, third, fourth, fifth, sixth, seven. Similarly, you will access each and individual elements of two-dimensional array by using indexing. Only difference is, in case of one-dimensional array, you are only mentioning one index. Here you are going to mention two such indexes to mention that the first element is present in 0th row, 0th column. Second element is present in 0th row and column. So here you need to mention both the row and column address to identify a particular element. Okay. So how to initialize? Okay. How to initialize a two-dimensional array? Okay. So next is your initialization of two-dimensional array. Okay. What do you mean by initialization? Initialization means assigning values to an array. I can initialize in two ways, that is during declaration. Or else during runtime using scanf statement, using scanf function. Okay. सो आप जब डिक्लेयर कर रहे हो तभी आप ले सकते हो वैल्यू, नहीं तो रन टाइम पे ले सकते हो. सो कमिंग टू फर्स्ट ड्यूरिंग डिक्लेरेशन. सो ड्यूरिंग डिक्लेरेशन how will you initialize the element, right? So if I'm saying during declaration, then for example, integer a of 2, okay? That means there are 2 rows and 2 columns. That means what is the size of an array? 2 into 2, that is how many elements in an array? 2 into 2 is 4, okay? So you need to write 4 elements or insert 4 elements into an array. I can write 1, 2, 3, 4. There are 4 elements of an array, okay? So here you might be getting confused that which elements to be stored in a row, which elements to be stored in a column. So you can see that whenever I am declaring it in a sequence, here in this case, a of 0, 0 is equals to 1. A of 0, 1 is equals to 2. A of 1, 0 is equals to 3. A of 1, 1 is equals to 4. If I logically represent this in an array, so this is 0th row, this is first row, this is 0th column, first column, 1, 2, 3, 4. This is how it will be represented, okay? You can also otherwise declare it as if you also declare like this is a correct representation declaration as well as initialization. So another way you can also write like this, integer a of 2. If you want more clarity during declaration, you can write like this. Take as a subset 1, 2, like this 3, 4. That means it will say that in one row you have 1, 2 element, in another row you have 3, 4 element. So this is also valid declaration. This is same as this. Here also 0, 0 will be 1, 0, 1 will be 2, 1, 0 will be 3, 1, 1 is 4. Okay. So this is your during declaration. If I want to initialize during runtime, okay, then I'll have to take the scanf, okay. In case of one dimension, I was using only one for loop to declare to initialize an array. But here you have 2 dimensions. That means you will have to take one for loop for row, another for loop for column. Now you can see that while storing elements into an array, first we store row wise. That is 0. You can say 0, 0. The first element is 0. The second element is 0, 1. So it is stored like this. First, while row is equals to 0, while row is 0, column is also 0. Okay. So while row is 0, column 0, the element is A0, 0. Okay. So that is equal to 1. When row equals to 0, column becomes 1. The element, the array is represented by the array is represented by A01. The element you are inputting is 2. When row becomes 1, column becomes 0, the element is A10. That means this element, this is 10. Initializing is to assign value. Yes, Anjali, you are right. So when the element, we are in row 1 and column 0, so the array is represented by A10, the element you are entering is 3. When row becomes 1, column becomes 1, the element is A11, okay, and the inputted element is 4. Here you can see that when the row is 0, you can see when the row is 0, the column is 0 as well as 1. When the row is 1, the column is 0 as well as 1. So that means from here you can see which for loop you need to take as the outer for loop, which for loop you need to take as the inner for loop. So always you remember that the parameter which changes most frequently, that should be taken as inner loop. So when the row is 0 over here, the column is changing from 0 to 1. So the loop you need to take for columns should be inside inner loop, and the loop you take for rows should be outer loop. Okay. So if I'll take initialization statement for here, for this, I'll write like this. Here I am taking I, this is I iterator for row and j iterator for column. Okay. So I need to write, as this is changing most infrequently and column is changing frequently. So I must be outer row, outer loop. So I starts from 0, I less than 2, okay, I plus plus. So inside this I am taking for loop for column, that is j equals to 0, j less than 2, j plus plus. Okay. So I need to write down the scanf statement. Scanf statement percentile d ampersand a of ij. Okay, that means when I equals to 0, this will run like this. The first I equals to 0 initialize. Second statement is I less than 2, 0 less than 2. Yes, it is true. Then it will enter into here. So the third statement that will be executed is whether j initialized to 0, j equals to 0. Then fourth statement is 0 less than 2. Yes, it is true. So it will enter. So this is I equal to 0, j equal to 0. So a of 0, 0. That means now you will enter the value for a of 0, 0. So fifth line will be executed, will be here. Now sixth here, so j will be incremented to 1. Okay. So now it will come to here. Check. 1 is less than 2. Yes, it is true. Okay. So I is same as 0. J is incremented as 1. So you will enter the value for a of 1. A of 0, 1. Okay. So this is your 8th statement that is executed. Then your 9th statement will be j is incremented to 2. So 2 less than 2. Now the condition gets false. So now I will be incremented to, I will be incremented to 1. Okay. So when I is incremented to 1, here it will check 1 less than 2 or not. It is true. Then it will enter. Okay. So I is 1, j is again initialized to 0. Okay. So when I is 1, j is 0, 0 less than 2 is true. Then it will enter. So this is what? 1, 0. Okay. So you will enter the value for 1, 0. Similarly, it will go on till the I condition get false. So now when I is false, you will come out of the loop. So in this sequence, you will enter first for a of 0, 0. Then you will value for a of 0, 1. Okay. Then you will enter value for a of 1, 0. Then you will enter value of a of 1, 1. Huh? So when I becomes 2, okay, so the condition is false, you will come out of the loop. So this is how you will declare, you will initialize two-dimensional array during runtime through scanf statement. I think it is clear to all of you how to declare, how to initialize a two-dimensional array. Okay. So if I want to print one-dimensional array, so this is your initializing, this is your initializing two-dimensional array. If I want to print one-dimensional array, then how I will be printing? The heading is displaying I++ will run last. Definitely. So see, you can see the sequence. First I equal to 0, then I less than true. If this is true, then enter. then j equal to 0, j less than true. If it is true, then enter j increment, then j increment, then j increment. When j becomes false, then it will come out of this loop and it will increment I. I think it is clear, Anjali. Is it? If yes, then say yes in the chat box. Otherwise, I can explain once again. Okay. Thank you. So, displaying the elements of two-dimensional array. So, for displaying, I need to use, for displaying, we need to use printf statement. Again, we'll display one by one element. Yes or no? So definitely, I'll have to take the for loop again for I equals to 0, I less than 2, I plus plus. Okay. Then curly braces start for j equals to 0, j less than 2, j plus plus. Okay. So here I will have to write down the printf statement. Printf percentile d. Okay. परसेंटाइल डी एक स्पेस देके मैं यहाँ पे लिख रही हूँ a of ij. Okay. So what I want, this is my inner curly braces. That means this braces is for this for loop. I want when this j is for, that means when I equals to 0, j will start from 0. J will go up to 1. When it is 2, it will come out. So that means this will print A of 0, 0. This will print A of 0, 1. Okay. So when j becomes 2, it will come out. So that means it is covering first row. I want after covering first row, it should come to second row. So for coming to second row, I must have to write down a slash n inside the printf statement. That means when it covers inner loop, that means it will print all the row elements first, then it will come to new line to print second row. So this is how you will display a two-dimensional array. Let me show it through your coding. Okay. So this is my array. I am taking the name of array is wow. This is a two-dimensional array having dimension 2 and 2. Okay. So you need to declare 4 element. So suppose I am declaring like this. Okay. So here starting of another bracket 56, 44. Okay. Sorry. Okay. So this is your static declaration. That means I am declaring, this is your static declaration. I am declaring like this. Okay. So simply while displaying the elements, I need to write down only for displaying. Okay. So printf two-dimensional array. Two-dimensional array is, here I am simply writing a printf statement. Then I need to write down for loop for I equals to 0. I need to declare the variable I and j as well, integer I comma j, because I am using this in my program. Every variable must be declared before using it. So semicolon, I less than 2, I plus plus. For j equals to 0, j less than 2, semicolon, j plus plus. Here again I am declaring another braces. So printf percentile d, this is my array, comma, a of I, comma, j. Okay. So only this a of ij. So when I will finish the printing the elements, when I will finish one row, after coming out of the row, I need to write down printf statement. And here it is less, and that means I want to return to new line. So I am saving this program. This is your array 2d underscore example1. So I am storing this program as a C program. So you can see whenever I am compiling, what is the error it is giving? A is undeclared. Achha. Okay, my array name is wow. This is not A. That's why it is showing me error. Compile. Okay. So it should have a semicolon. That's why it is showing error. Now it is error free. Okay. So if I will compile this program, now you can see it is showing me the two-dimensional arrays 12, 33, 56, 44. So if I want, this also should be displayed in the new line. Here I have to give new line character so that the first row will also be displayed in the second column. So you can see this is my array A of, and this is 12, 33, 56, 64. Okay. So if I give tab over here, so this will be more prominent. Now you can see 12, 33, 56, 44. Okay. So this is how you will display the array. Okay. So this is my static declaration. That means I am declaring the array and initializing the array in a single statement. Similarly, I can also take the for loop to take the input for an array. Okay. So here you, while declaring an array, okay. Now let us see. I forgot to mention this row address. So row dimension. What is happening over here? So it is not giving me any error because you have two columns. Okay. So if you have 4 elements and 2 columns, definitely the row is ultimately 2. That means it is just like you have given 4. There are 4 people over here. There are 4 people over here. If I say that you all 4 have to sit in 2 columns, okay? So definitely 2 column is in one column. This is 2 columns. 2 columns means in one column definitely 2 people will stand. Okay, so in another column another 2 people will stand. So this is definitely forming a row. Okay, so if I am saying that there are 4 people and you have 2 columns, so by default it is 2 rows. Okay, so it is not giving me any error. Okay, so let us say if I miss the column dimension, then what is happening? See, if you are mentioning is the column dimension, then it is giving me error. So you need to remember that in a 2-dimensional array, you can skip the row dimension, but you cannot skip column dimension. Is it true? What happens with tab? Actually, when tab is 6 spaces, okay? So whenever I am giving tab, so it is giving 6 spaces within element. But if I am exclusively giving 1 space or 2 space, that will include only 1 space. I think it is clear, Anjali. Tab is a white space character. Tab means 6 spaces. So it will give 6 number of spaces between each element. Clear? Okay. So you can see you cannot leave the column dimension. So this is giving me compiler error, but you can leave row dimension. Okay. Okay. So this is let me modify the same program to suppose here I am not declaring the array elements, right? Here I am not declaring array elements. I am inputting the array elements through for loop. So let me copy this code as it is. Control C, Control V. Here I am giving another printf statement. Printf enter 4 elements into an array. Okay, that means here you have mentioned 2 by 2, so it is 4 elements. Okay, so here I need to write down scanf rather than printf. And remember that in scanf there is no white space included. Okay, so scanf must have ampersand. And here also you don't have to write down any slash then over here. Okay, so simply this is a for loop, nested for loop. I am taking I for row, j for column, and here, ma'am, you are now doing dynamic initialization. Okay. Okay. So here I am taking the values for row during runtime. So if I'll compile that, so you can see it is error free. Now I have to input 4 elements. So 12, 22, 33 and 44. Okay. So I have entered 4 elements. Now you can see it is displaying 2-dimensional arrays 12, 22, 33, 44. Is that clear? Okay. So if I run the program second time here, then you can take another set of elements. This is 11, 44, 45, 67. So whatever element you are taking during runtime, that is only displayed. You need not have to go to the program again and change the initialization here. This is the advantage of your giving the elements during runtime, okay, or inputting the elements during runtime. So you can check for multiple inputs whether it is working correctly or not. Okay, so it is always a better practice to write down the aim of the program or the problem statement before writing the program. So this is a program. This is a C program to input and display a 2-dimensional array. Okay, so whatever changes I have made, I need to save it again. Okay, so this is your second time 2-dimensional array. You saw how to input the elements for an array, how to display the elements of an array. Okay, then coming to how the elements are stored in memory. Okay, so coming to the point, how the elements are stored in memory. We can store 2-dimensional array in 2 ways. Okay, we can store this. The heading is storing 2-dimensional array in memory. Memory means RAM. Okay. There are 2 ways to store 2-dimensional array in memory. One is your row measure row measure order, second is your column measure order. Okay. So first of all, let me graphically show you what is row measure order and column measure order. Coming to your row measure order, whenever I am saying row measure, how I declare the two-dimensional array? Suppose I am writing integer a of 3 cross 3. This is my two-dimensional array. So how will I represent logically 3 cross 3? So this is represented like 3 rows. This is first row, this is second row, this is third row. You will have 3 columns, 1 column, 2 column and 3 column. This is logically representation of two-dimensional array. So this is my 0th row, first row, second row. This is my 0th column, first column, second column. So this is 0, 0. Let it is 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay. So if I store these elements in a row measure fashion, okay. So in a row measure fashion, I need to pick one row at a time. Okay. That means if I expand this, okay, in memory it is not stored like this, it is stored like in this way only. Okay, so I'll pick row by row. This is a of 0 0, that is 10. Then this is 20, a of 0 1, then 30, this is a of 0 2. Okay, then I'll store, then I'll pick second row, then I'll pick second row because it is a row measure order. So the elements will be stored in a row fashion. Then the first element in a second row is 40. This is 1 0. So this is a of 1 0. This is 40. Then 50 is a of 1 1. This is a of 1 1. This is 50. Then 60, that is a of 1 2. Then I need to pick, okay, then I need to pick third row because it is a row measure fashion. So in third row, first element is 7. This is a of 2 0. So this is a of 2 0, 70. This is 80. This is a of 2 1. Okay, so this is 90, a of 2 2. This is how the elements will be stored in a row measure order. Then how to address this element? Okay, if the first address is that is 1000, the first address is called as base address. If the base address is equal to 1000 and it is a 64-bit compiler, so every element requires 4 bytes of memory. Okay, so for this is 1000, this is 1004, this is 1008, okay, this is 1012, like this. So the first element will be 1000. Let me write in different color. So this will be, the first address will be 1000, second address will be 1004, third address will be 1008 because each occupies 4 bytes. So this is 1012. The starting address is 1016. This is 1020. This is 1024. This is 1028. This is 1032. Okay. So if I randomly pick one element, so this is my 0. If I want to, I know only the base address. If I know the base address and how many byte each element is occupying, if I want to randomly calculate any of the address, then how to calculate it? There is a formula in row measure. You can see that here on, suppose I know base address is, here base address is 1000. Okay. I know each element is 4 byte. I want to calculate what is the address of your A21. Okay. So this is my address of A21. So I want to calculate the address of A21. Okay. So this is my ith index. This is my jth index. Okay. And the dimension of array is m cross n. M is 2, n is 2. Okay. That means because we have declared it as a, sorry, m is 3 and this is your m, this is your n. Okay. So this is a 3 cross 3 array. Okay. So sorry, this is not 2 cross 2, this is your 3 cross 3. Okay, you have a 3 cross 3 array. This is called as dimension. For dimension, I am taking another variable m and n. I need to calculate a of 21. So what is the a of 21 address? This is A32. How it is calculated? It is calculated as base address plus. Okay, base address plus. What is the row? What is the row? This is row index. Row index is 2 into. Okay, row index is 2. Then what is the dimension, column dimension? That is 3 plus. What is this j value? J value is 1. Okay, multiplied by size of each element, that is 4. Okay, size of each element is 4. Okay, so 2 into 3 6. Is it correct? 1000, 1004, 8, 12, 16, 20, 24. This is 1000. Sorry. Let me verify. This is 1000. This is 1004. This is 1008. This is 1012, this is 1016, this is 1020, this 70 is 1024, this is 1028, this is 1032. So what is this index? This is 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1. This is 2, 1, A of 2, 1. Yes, it is correct. Let me check the formula. Yes, it is base address plus I into n plus j multiplied by width. Yes, this is correct. So why I am not getting the exact result? This is 2 multiplied by 3 I into n plus j, 7 into 4. This is 1000. This is 1028. So what is the address of 10? It is this address. Correct. This is getting me 1 because this 1032 is the base address of A22. The base address of A21 is 1028. This is. So my answer is correct. Is it clear? Yes, 1028. Okay. So from now you can see So this is to calculate the address of Aij. Okay. So this is base address plus, okay, I multiplied by n plus j into w. W means the size. Here I is row index, j is equal to column index, base address ba equals to base address, m is equals to row dimension, n is equals to column dimension, w is equal to size of each element in bytes. I think it is clear. Okay. Now let us take another example and check, okay, whether I am getting correct result or not. What is the value of A10? Here I am calculating A10. Okay. This is A10. So here I is equal to 1. Base address is 1000. Okay. I is 1. So 1 multiplied by j is 3. Sorry, n is 3. I multiplied by n plus j. J is 0. Multiplied by width of the each element, that is 4. So 1000 plus 3 into 4, 12. So that is 1012. So this element address is 1012. Now it is verified. Are you all clear how to calculate the address of any particular element in a row major order? Yes or no? Just drop a comment if you are clear. Okay. Then coming to your column measure. Coming to column measure order. Okay. How the elements are stored in column measure order. For example, if I am taking the same array element, that is integer a of 3, 3. Okay. So logically I am representing the array as 3 rows and 3 columns. This is first, this is second. Okay. So 10, 20, 30, 40, 50, 60, 70, 80, 90. The same elements are there. If I store the elements in column measure order, so this will be stored like this. So here I'll consider the column. This is 0, this is first, this is second, this is 0, this is first, this is second. So first element will be a of 0, 0. Second element will be a of 1, 0. Third element will be a of 2, 0. That means it will pick one column at a time. Okay. Then it will pick second column, then third column, right? So a of 0, 0 is 10, this is 40, this is 70, next 20, 50, 80, next 30, 60, 90. It will store like this. So 20, 50, 80, this is a of 1, 1. This is, sorry, a of 0, 1. 0, 1. A of 1, 1. A of 2, 1. then A of 0 to. Why is it horizontally stored? See, to avoid the, because we already discussed na कि the array elements are stored in consecutive location. So this is how consecutive, that means it is stored in a neighborhood. If I store like this, so is it satisfying the consecutive memory location? That means this is my 1000 address, this is 1004, this is 1008. So after 1008, this must be 1012 location, but this is starting from somewhere else. So this is not satisfying the criteria of consecutive memory allocation. So though logically I am saying it is stored like this, but actually in the memory it is stored like this. Okay, clear? So 0 to A of 1 to, this is A of 2 to. देखो, अगर हम ऐसे ही 2 डायमेंशन में स्टोर करेंगे तो फर्स्ट एड्रेस क्या होना चाहिए 1000, सेकेंड एड्रेस क्या होना चाहिए 1004, थर्ड एड्रेस क्या होना चाहिए 1008, फोर्थ एड्रेस, इसके बाद जो लोकेशन होना चाहिए 1012, 1016, ऐसे ना जो भी मेमोरी होता है, मेमोरी भी तो ऐसे ही रो कॉलम में होता है, तो 1008 के बाद ये 1012 जितना भी मेमोरी होगा, बट हमने क्या किया यहाँ से ब्रेक करके यहाँ स्टोर करना स्टार्ट कर दिया. सो यहाँ स्टोर करना स्टार्ट, दिस माइट हैव बीन सम 2020. सो 1008 के बाद 1012 आना चाहिए, नॉट 2020. सो दिस इज नॉट सेटिस्फाइंग द कंसेक्यूटिव क्राइटेरिया. हमारा एरे का क्राइटेरिया क्या है? ओके ओके, ठीक. So how to find out the address? Here the location A of j, I j will be calculated as base address plus j into m, okay, plus I into w, okay. So what is the base address here? For example, if I am taking the calculating the address of A11, so the base address is 1000. What is J over here? 1. What is the dimension of M? 3 plus 1 multiplied by 4. So 1000 plus 3 plus 1, 4 into 4, 16. So 1016. Now let us take, this is 1000, this is 1004, this is 1008, this is 1012, this is 1016. So the starting address of 11 is 1016 if I am storing it in a column is order. Is that clear? Okay, so by this we end today's class, that is 2-dimensional array. So next class we'll start some other topic. Have a good day. Bye bye.